Okay, so we have fitted the first spectrum, but you know, the reason for the name massiveOES is that we really allow the batch processing of the data. So what we could do now is the maybe second most important button in this software, and that's run fit for more measured spectra. So let's just press that, and now it opens the pop-up window, and here we see that here we have all the available spectra that we have in the measured file. So we have 50 spectra corresponding to some spatial resolution in our measurement, but of course it can be whatever you have just measured. So basically the number 0 is already done, so I don't want to fit that again, but I can do all the others. Okay, but we don't want to wait too long, so I just unselect all and select only the first, yeah, until the number 6. So then we have take initial values from expression. When I have here num minus 1, it means that if we start to fit the spectrum number 1, so now we have done number 0, so number 1 is the next one, still not processed, I will take as initial estimate of all the parameters all the numbers that were in the spectrum 0. And when we move to 2, it will just take the numbers from 1 and 3 from number 2 and so on. So basically I would be satisfied with that, and I'll just press OK and see what happens. So here it goes, and it fits and changes everything, and I think it goes quite quick. So it will be done in a few seconds. Okay, it was done before I ended my sentence. And here you see, here are the results, and I can just go through that. If I press arrow up, I just see how the temperature changes in the report here, and that's quite interesting. Okay, so I can do that basically for all the spectra in the file, which would not be a problem. And okay, so let's say that we have already done almost everything, so we have 0 to 6, but there's still 40 to go. So I want to do all of them, and we ended by 6, and I don't want to click all the checkboxes because it's quite many, so I just write range. Okay, sorry, someone left my caps lock on. This is probably case sensitive, so we should write it in small numbers, and I will write range 7 to 49, or 50 actually we can do, and that will take all the spectra that are left. And again, this is quite a good assumption to take it from the preceding spectrum. Here you see that it already has written all the numbers that I'm going to fit at the moment, and you see that it ends at 49, and we have actually 50. So if we want 50, we always have to put here a number greater than the one we want to take. So now the 50 is included, and we can start that. Still going on, and we have to wait for the results. Okay, so I've posted the video, so you didn't have to wait to see all the spectra I did, and you can see that at the end of our measurement, at the end of our spatially resolved measurement, we have measured just total rubbish. This is purely noise, and still managed to fit some temperature. So here we have 684 Kelvin plus minus 162, so the error is 23%. This tells you something about the error, because the error is estimated from the residuals of the fit, and if we compare that to what we see here, I think that we can safely state that the error is underestimated. So basically the last spectra looked really like a crap, but if we go up, it's better and better, so we can have the image of what we can trust. Yeah, and it looks like this. So now we have all the fitting done. We can save our project again so that we don't lose that. So we have already made the file, so we just overwrite that. Okay, so the file is overwritten, and we also probably want to export the results so that we can make some nice plots of our results later in some other program. So here's another important button, export results, and we go to here, and of course we should select some proper name like export CSV. You have seen that I have selected ending CSV because CSV is really the format of the exported results. Now it does some calculations, so you had to wait a bit, but it's already done.